Hello everyone, in this content today we are trying to learn about time series smoothing. So what is the need of this time series smoothing? So this is done to remove the variation or any types of noises in the data. What happens sometime is after applying the cloud masking, we may have some missing values somewhere. And this also helps to make the data continuous, meaning it will help you or help us to have the data available in those points as well. And the other thing is that this smoothing also helps us in seeing the patterns and trends very nicely. So there are different algorithms, and in this particular video we are trying to see the examples. So the links are in the description, and my attempts will be to explain these examples briefly. I'll try to explain them as much as I can. So here is the very first sets of codes, and I have already run this, and we see something like this here. So the original one here is in the dotted lines. So this is the original NDVI curve, and after that we see this red one, which is the moving average, and there is some difference between these two line curves. So the red one is something better than the original one. So let's see what's in the code. So we quickly go through this one. We have the sentinel 2 here. We have the geometry. You can see this in the map section as well. We have added this as the layer. We center it as the object. We have the visualization parameter. We filter our sentinel 2 dataset with some dates and by cloudy pixel percentage and bounded by our geometry. Then we have the cloud masking function. Then we add the NDVI by this function, and then after we have the main thing starting from here. So we have specified this date. So we have the 30 days. So this is something called a time window, and by time window it means that we want to have all those images within that 30 days, within that time window. And for that we have here this ee.join.saveAll. So this will help to join all the images within that time window, just the earthengine function here. And then we have this here ee.filter.max difference. So this will match all the images captured within that specified day of the source image, and this days is being converted into this different unit here. And then we have this left field and right field. Now we select the NDVI, and then we're applying this join function here, and then we can see here in this join collection we select all those images here. We get the images, and after getting those images we add this mean, or we are finding the mean of all those images within that time frame. So that is the main objective here, and we are renaming it as moving average. So after getting this, now it becomes easier, and then we apply this UI.chart.image.series. It selects the two different bands, and after that we have here series specifying the colors, very important for the visualization. The first one is for the original NDVI, and the second one is for the smooth NDVI. And after running this we get this. So this is something called as the moving average. So this is the very first example. So in this example, we just get the images within that 30 days, and then we mean it. We do the mean of those images, and that is the moving average. And for that, we have these different joining functions, and this is also in the other examples there. So here is the second example, and this one is the linear regression moving window. The thing is the same. Here again we have this original one in the blue and the smooth curve in the red. So similar to the previous one, let's go through this. We have the signal to our data set. We have the point here, and then we have this data set filtered with some dates and the sorted by the cloud cover. We add the NDVI, and here we are doing something new. This is adding the bands, dividing by some constant and renaming it as time. So we are preserving the time properties. And then here is the main function. So this is the linear function. It is selecting that time, multiplying with some scale, and adding with that offset. So this is the way to do the linear regression in earthengine, and we set the time properties, and this whole thing is renamed as NDVI. So this is the NDVI that is going to be smoothed, and then we have here date e dot date, and from that date we advance. We have the first date, and then we also have the second date, or so this is the time frame here. So within the window size, for example, if this is 30, it goes back to 30 days before, and within the 30 days. So here we see the negative sign here, just to say it would be the back or something, beginning of the day. And this will select the time and NDVI, and it's being reduced by e dot reducer dot linear feed. And we will return this one here. This apply feed is being applied, and we will return this. So this is the function to apply linear regression equation, and after that we have this one here, function to reduce time stacked linear regression results. And for this we need fit IC. So here we can see we are filtering it by the dates, and we do the mean and rename it as NDVI. And we apply this to our original one here. We can see this one is the filtered one at the very beginning. So in this image collection, we apply this one, and let's see. So we apply this linear regression one here, and then after we have the dates, we have the window size, we have this one fit IC here, and then we have the smooth one. So after doing this, applying this function, we have this image collection being renamed. Sorry, the bands of the image collections being renamed. So the first one is smooth, and the second one here is the original. And then we apply this UI.chart.image.series. We select the two different bands, and then we get this. So the objective here is, what we are doing is we get the data, our image collection, we add the NDVI, and then we have this linear regression equation, and this is the main thing here. And After that, we reduce the time stacked linear regression results, and then we map this function. And after mapping this function, we get the two NDVIs. One is renamed as smooth, and the second one is renamed as original. So that's the thing here. And then here we have this smoothing that is called the Savitzky-Golay smoothing. And again, the objective is the same, only the process might be different. So here we have the original NDVI in blue, and the red one, the smooth one, is also there. So we have two different NDVIs, and the process here is a little different. So we have, again, we again have our central image collection, we have our geometry, we add this as the layer, we center it as the object, we have our start dates and end dates. So beginning from 2017 to 2018, we filter our sentinel tool, we have the cloud masking function, we add this cloud masking function, we add our NDVI, and here the main thing starts from here. So for this, what we're doing is, and we select some intervals, so maybe something within the 5 days. In the first one, in the first example, we saw that it was being done for the 30 days, and for this case, however, we are doing this for the 5 days. So anything within that 5 days will have something applied, so something being done. So we have our end date to different end date and start date. We're subtracting each other. We get that in days, and from that first day to the last day, that is the total days, and we will have the interval or the sequence being added as the 5 each time. And then here is the main thing. So we create here the empty collection, this one here. This in this sequence we are mapping this function, and in that we have this ee.image. This is the empty image being renamed as NDVI. So the value will be in the float, just the way of notation. And then we are setting the properties. We will also have the properties there. This is so the system index will be formatted as day, and there will also be the time start, and this will also be the day, and just this being done in the milliseconds. So in general, we are adding the time properties in that blank image, and the type, or this will be as the interpolated, some properties being added here, and we will return this image, and this will be our image collection. So this is image collection dot from images, making this as the image collection, and this will be here. This will be here as the we have the symmetry elements, or the symmetry features with NDVI. So this is the blank image, and then we have different joins. So we merge this this original one to the blank image. So this NDVI call, we can see this one is the original one with the original NDVI. So we are merging two different image collections, and then after we can interpolate after merging those images. So in this here, we are mapping this function. We have this time image. From that image, we select the time start properties. This is being renamed as timestamp, and then from that time image, we are updating the mask, and then we return the image. So something is being masked here, and we are returning the masked image. And after doing that blank image, which was being done for each and every for the 5 days. Now what we're doing here is this is the original time frame, that is the 60 days, and this is again being converted into some milliseconds. And then here we have some sets of the joining function. So the first one here is the filter.max difference. Second one is the less than or equals to. Then after the greater than or equals, then we use these two different joinings, making this filter 1, and again and then we make the join 1, and again this join 1 is being applied for the next one. So there are different joining functions. So in general, why is this being being done just for the interpolation, let's say? But this again is to note that we need to understand about these joinings. We are joining two different collections, or two different image collections. But in overall, what we get here is this last one here. So we use this previous joinings, and we get this final one here. And then we apply the linear interpolation to each image, and after that we get this something has to be equal to this interpolated. And then here is the interpolation function, and in this we are mosaicing. We get some images, we mosaic this one, we get the after image, and we are again mosaicing. We have this timestamp properties, then we are finding this time ratio, and this is the way to interpolation, let's say, and this is how it's being done. And then after finding this time ratio, we have this subtraction between the before mosaic and after mosaic, and then we have the result with image being maxed from this interpolated, and then we return this image with the image properties. And then here we are selecting the NDVI from that image collection, and this whole thing is being done as the interpolated image. Now we finally apply the Savitzky-Golay filter. So we now learned that everything that was done before was just for the preparation for this function. So this function comes from this open earthengine library. So this is the plugin for the JavaScript API, and then we have this again maximum difference filter, and we have this default something function here. So this is the preparation for that main function. And then we have this distance function, and then we have some applying a smoothing of order 3, and here we can see this is being used in this function, interpolated, and then maximum difference filter, we have distance function, we have order, and this is being selected, and then we are renaming it as the smoothed one, and we are using this UI.chart.image.series, and then we get this something like this. So what we see here, again to re-summarize, is we have our original collection, and then we have our empty collection. We created the empty collection, and from that two different collection we apply different types of filters, just with the different properties, some long sets of the filters for that two different collection. But the objective is that to get that final images for the preparation for that function, for the OEL function. And after doing this, we finally get some NDVIs, and this has been renamed as smooth, and then we can apply in the chart. So this is the main thing here. But please again go through this one. I may not have been able to go through the codes very nicely and very, in a very crispy manner. Well, again, I just tried to explain this one. And the final one here, let's go to the final one here. So this is this example also uses the Savitzky-Golay smoothing, and we see the same thing here. So this is the main output here. We have the band mean across images, and we have the smooth derived. So here this is being done for the Modis image. So here we have our SOTM, a point here, and our image collection. We load our library, we filter it by some dates, we select the first one just to check, and then after we select these surface reflectance. So this is here is the nice way to select all the bands, which starts with sur_reflectance, surface reflectance, and we reduce it by mean, and this gets the chart here, and we apply this cloud masking function, and we can print this again. So this again gives this band mean across images, and here some algorithm has been applied for the tear and shadow, just to remove the shadow mask, and then we have the next chart again, band mean across images after the masking of the cloud. And the main thing to understand here is this function. So this is for the Savitzky-Golay filter, and this function takes the collection, image collection, filter, some distance function, degree, band of interest, estimation collection. So these are the parameters for this particular function. And the collection means the image collection to which we are performing the filtering. Filter means we are the moving of the Windows filter. Some distance function, it specifies how to compute the distance between two images. And then we have the degree. Default is 3. So band of interest, and the estimation collection. So what I wanted to say is that, again, to apply this filter, Savitzky-Golay, we have to understand the function, but before that we have to understand this Savitzky-Golay smoothing thing. But again, our objective is just to go through this one and just try to see one. But this is the function, and we can see this in the document page as well. And this document page gave us this particular example. So then we have this function being applied here. We are doing this in this Modis. Then we have this filter, and then we have this function. This is the distance function. So it is specifying how to compute here, how to compute the distance between two images. Just to say that one. And here we are subtracting two different images from the getting of that time start, subtracting between two images. And here we have the value 5. So this is the polynomial degree. And then we are selecting our bands. So we are selecting all those bands, surface reflectance bands. And what happens is, after applying this one to the Modis, we have numbers of bands here. So you can see this one features here in the first one. Let's see. So what we're getting is, we are getting the bands. Along with the bands, we have other addition of bands here. So many bands being added here. So we now understand from this following lines is that this is the smooth data, this 0, 1, and this one is the smooth derivative. In general, we are selecting the two different bands. So we had selected this 5. So this is the polynomial degree. So we have 5 different things, or 5 different renamings of those bands, and we get this. Like something like this here. So this is the smooth data, and this is the smooth derivative. So in general, these bands are being concentrated at the 0 value, and for the derivative, it's also being centered at this 0 value. And in this library, or in this package, when we write this oel.refs, it shows what types of functions are being used. So it shows that we have 2 different functions. So the first one is the Terence shadow, and the second one was the Savitzky-Golay time filter. And this is the overall picture of the smoothing. We tried to learn some of them, not exactly learn, but tried to be aware of this process. And to summarize, I think this will help us to understand the other types of filter as well. But I have to say, we should be learning about the algorithms, or the smoothing functions. So I hope this was helpful at some extent. If this was helpful, then thank you. Thank you for watching this.